right, today we are talking about the Cartesian plane and trig functions of non-acute angles. So this is kind of where we get into a little bit more than just degrees. We start looking at what radians actually are. Radians are another way to measure around a circle. For the most part, kind of like we use degrees within a circle, we use the radians as well. We also use this with triangles, which we'll see kind of later on once we start talking about the unit circle. For the most part, if you kind of look at a circle, okay, in degrees, because that's what everybody is kind of familiar with. If you were on the coordinate plane, here would be 0, and then 90, 180, 270, and then 0 and 360, pretty much the same. Okay. Radians, okay, a different unit of measure that we use, also does the same exact thing. We go in counterclockwise. We start at what we call 0 as well, but then we'll go to pi over 2, pi, 3 pi over 2, and then 2 pi. So one full rotation in radian is 2 pi. Radian is measured in pi for the most part. So a half or 180 degrees would be pi. These are pretty much match up verbatim. So 90 is pi over 2, and 270 is 3 pi over 2. There's a way to convert from degrees to radians, okay, and then radians to degrees, which you'll need to know. So when you're converting from degrees to radians, so say for instance I ask you for something in radian mode, okay, convert 250 into radians. You're going to multiply the degree by pi over 180. This will help because the degree, remember, degree in radians, 180 and pi are both the same measure. They're halfway around a circle. If I am putting degrees on top, then degrees has to go on bottom. Kind of similar to some of the other, like, well, I don't know, whenever you're in chemistry and you're like measuring from centimeters to meters and meters to and so forth. So in this case, I would then divide. So I divide out 0, I would get 25 pi over 18, which then I believe that's pretty much it. 25 and 18 can't really be simplified to anything else. For some reason I was thinking 25 is divisible by 3, but it's not. And then if you were given radians, which this is one that most of you will probably be like, you know what, I don't know what radians are to kind of start because I'm not used to them, but I know what they could be in degrees because I know degrees so well. You can convert radians to degrees. So we're going to multiply the radians end by 180 over pi. What that'll do is if you have pi in your numerator and denominator, those will cancel. 180 divided by 4 is actually 45. And then times 7, that would give us 315 degrees. Okay, so if you're not super familiar with radians to start, the unit of measure, then you can just transfer it into degree mode, which is fine. So here's some vocabulary, mainly about the circle and going around a circle with degrees and angles, or degrees and radians. The initial side of an angle, the start side of an angle, it always starts on a positive x-axis. So anytime that you see, this is what we call the initial side. The initial side will always start here on the x-axis. It'll always start positive. Terminal side is the side that swings to determine how wide the angle opens. So sometimes an angle will be like this. This will be your terminal side. Or maybe it'll swing around here, down to here. This will be your terminal side. It could also go clockwise as well. So there's different types of movements, either clockwise or counterclockwise, which become positive or negative, which we'll get to in a second. Last, there's something called standard position. It's the angle with the initial side on the positive x-axis and its vertex at the origin. What we work with is standard position, so you don't really have to worry too much about that. It's just getting the initial side and the terminal side of the angle. Initial side never moves. The terminal side is always the one that moves, okay, and goes around and around, either clockwise or counterclockwise. So when the terminal side swings up to form the angle, or counterclockwise, it's what we call a positive angle. So for example, here is my initial, okay, initial side, the angle, foci, okay, and I'm swinging this way. Maybe I swing the whole way over here. That would be a positive 180 degrees. However, negative, if I go from the initial side and I swing the opposite way, which is clockwise, then that would be I moved a negative 180 degrees. Or if you're looking at it in radians, you just swung pi or negative pi, depending on the outcome. And again, if you're not familiar with those, you have those conversions that you can use. All right, so a reference angle. A reference angle is a positive. It is a positive acute angle formed with the x-axis. It's how far the terminal side is from the x-axis in each quadrant. Okay, so if we're looking at a reference angle for a 240-degree angle, the big word here is positive acute. So I'm going to go here. Okay. This, remember, this is 90. This is 180. This is 270. So if I'm going this way, counterclockwise, okay, 240 is going to land me right about in here. What I'm looking for is the positive acute angle formed with the x-axis. The acute angle, so let's just say you're like, you know what, I'm going to keep swinging it around. That would be more than 90 degrees. That wouldn't be an acute angle. You're looking for this angle here. Okay. So in this case, you would take 240, subtract 180, and you would get a 60-degree angle. So 60 degrees would be my reference angle here. Example number 4, state the reference angle for 7 pi over 4. So I know I'm just going to do these again. Pi over 2, pi, 3 pi over 2. None of those are pi over 4, but you can convert them. Like this is the same as 2 pi over 4. This is 4 pi over 4. If you're having trouble figuring out where they are, this is 6 pi over 4. And then this would be 8 pi over 4, technically, if we were going to keep going. Or you can also convert it using degrees. You can convert that into degrees and then find it using that. Now, it's going to be in this quadrant here, okay, 7 pi over 4, quadrant 4. And if you're looking at it, our acute angle that's formed with the x-axis is actually going to be this angle now. Okay, so what you'll do is you'll look, okay, that's 8 pi over 4 because that's one full rotation around. So 8 pi over 4 minus 7 pi over 4 will give us pi over 4. 1 pi over 4, which is what our angle measure is going to be. All right, and then we've got coterminal angles. So coterminal angles have the same initial side, it's a positive x-axis, and the same terminal side. So they end in the same position, they're just different rotations. So again, if you were kind of looking at this, here's my initial, and my terminal was 240. And so here's 240. If I would go, so that's that way, if I would go the opposite way and go negative, this would also be the same as negative 120. Those would be coterminal angles. So here it says find the coterminal angle between 0 and 360 and state the reference angle. So it's got to be between 0 and 360. We're at 900. So let me go ahead and draw this out here. So one full rotation from 900 means that I would subtract 360. So if I went around, going around in a negative way, I guess here. I'm going to subtract one full rotation. That's 360. I'm going to get to 540, which is still not at that measure. So I'm going to go one more time around 360 again. And I would actually land, it says here, at 180. Since 180 is on our x-axis, there is no reference angle. We're going to do the same exact thing here, negative 520. So in this case, I want to get in between 0 and 360, so I'm going to add 360. So negative 520 plus 360 is negative 160. So I'm going to add 360 again, and I'll get 200. So add 360 again here, and then I'm going to get 200. So this is going to be 90, 180, and 200 is here. And since this is 180, my reference angle is just going to be the smaller measure, so it'll be 20 degrees. And then for coterminal angles between 0 and 2 pi, in this case, for example 7, we can also say that this is going to be 12 pi over 6, just to kind of help us along. So if I'm got 25 pi over 6, I'm going to subtract the 2 pi, which is 12 pi over 6. I end up with 13 pi over 6. So if I'm subtracting that, I'm going positive way. And then if I do one full rotation again, I subtract another 12 pi over 6, because 13 pi over 6 is not within that. I'm going to end up with pi over 6. So I'm actually going to end up here. And pi over 6 is going to be my reference angle, because that's the angle measure that is going to be below the 90 degrees. Here I've got 5 pi over 4. So 2 pi is going to be equivalent to 8 pi over 4. That's going to help me whenever I'm trying to figure this out. So I'm going to add 8 pi over 4 to this, and I'll end up with 3 pi over 4. I'm just going to draw this out again so you can see it. So in this case, I'm adding something clockwise. I've got 3 pi over 4. 3 pi over 4, so think of it as, like, if I go here, this is pi over 2, which is 2 pi over 4. So 3 pi over 4 is going to end up here. And then this is 4 pi over 4 because it's just pi. So my reference angle is just going to be pi over 4. All right, so here's talking about finding exact trig values from given the point. So use a point that the terminal side goes through, or a given ratio. We can construct a right triangle to calculate exact trig values of an angle. So the terminal side of an angle passes through the point -4, 7. Find the 6 trig functions of theta. I think this is time for another video. We'll catch this in our next video that we do.